Hello everyone and welcome to another AP Computer Science video. Today's video is going to focus on a second type of loop that allow us to use, the idea of iteration to effectively make complex programs. We've seen a while loop, and a while loop is a very useful tool and allows us to continue some section of code as long as a condition has been met, but it does require some setup. Usually at least one variable that represents kind of the management, what we call the sentinel value or counter value, that determines whether the condition is true or false. And then in the actual body of that loop, some work that happens that potentially would cause the sentinel to change, which would in effect change the evaluation of the condition. And so these are useful, but all those different parts we have to kind of remember and manage, and that's fine. But this new version of a loop that we're going to look at is kind of tries to compact it all together. It's purely a visual change. At the end of the day, anything that can be done with what we're going to see today can be done with the while loop, and vice versa. So the idea is that we have to pick what we're comfortable with, and sometimes we'll see particular problems lend themselves to a particular style of loop, but there is no requirement, and it's just a matter of, do you know what the components are and which ones would you prefer to use? So this is very much a kind of an optional. We need to be able to read it for the AP exam, as you will see both versions, but in terms of usage, it's purely a matter of what you think is useful. I will say from personal experience, I use this type of loop much more often than a while loop, but again, it does also matter in the context of what the problem happens to be. So we're going to make a new class in our iteration package. So I'm going to right click on it and say new Java class. And we'll call this for loops. Not for as in the number, but for FOR. So for loops. So we've seen while loops, and today we are dealing with for loops. So we'll talk a little bit about them in our example. And so a for loop is essentially a while loop, but the three parts of the while loop, the sentinel value creation or initialization, the condition that needs to be met, and the change that causes the sentinel to eventually cause the condition to be false, those three components can actually be built or piled in together in one section of our for loop, which makes them a little bit easier to read than a while loop, and that can be a pretty big deal. And again, it is a matter of convenience, but we can see that this will end up being, for certain scenarios, very, very convenient. And so the first example we're going to do is pretty much the same example we did last time, the first one we did, which is counting the numbers from 1 to 10 and printing them. And this is actually a really easy thing to do, and in my opinion, the for loop is a little bit more clean, purely because the work and the initialization are all in one line. So before we write out our code, let's go ahead and write some notes real quick. We'll say, for loop can do any work that a while loop can do. Enter. They're interchangeable. Usually a matter of style choice. So we'll go ahead and say, and so here's where it starts. I guess the details. We'll say for loops usually have three components in there, and we'll call the header of the loop, which is basically the part above the body. So the while loop, basically the header was the keyword while, along with the parentheses and the Boolean condition or Boolean expression that was evaluated. And then the initialization of the sentinel was before the loop, and then the change of it would happen inside of the body somewhere along the lines. And so we'll say that the for loop header combines all three of those things with three main parts. So we'll say for loops usually have three components in their header. So we're going to say the first part, we'll say sentinel initialization. Right? So this is the creation of that variable, the counter, or the sentinel, or the manager, whatever you want to call it, that controls the loop by being usually related to the condition in some way. Right? And it really does matter. Sometimes we don't actually use a sentinel in that way, but it is there and it does exist to do that. The second part is the Boolean condition. Again, this is the same exact idea as the while loop. We're saying what must be true for the body of this loop to be run or executed. And if it's true, we run the loop. And if it's false, then we move past it and move on to the next section of code. So it's exactly the same as the while loop. And the third part we'll call the update. And I say update instead of, for example, increment, because it's not always an addition of a number. We saw many examples where we increased the number by 1, the sentinel value by 1, or we decreased it by 1. And so depending on what you're doing, or added +2 or subtracted 2, whatever you're doing, the point is that the update is a change that has to occur one time every iteration. And so a for loop will conveniently place this and implicitly call this code at the end of every body, and we don't have to write it more than once or in the body itself. So it's kind of contained within the header, and so our bodies become a little bit simpler to read. So here we go. So let's go ahead and do an example. And it is the keyword for, so we'll say the format looks like the following. Right? The keyword for, a set of parentheses where our conditions are, and so we'll say our initialization, and then a semicolon. So this is usually a statement, both a declaration and assignment of a variable. So we might say int num equals 0 or something like that, and that's the initialization. It's usually a statement that creates a variable and assigns it a starting value. Our condition is also followed by a semicolon. This is a Boolean expression, returns true or false. This is exactly what the while loop had. The while loop parentheses had just the condition portion inside of it. And the last part is the update. And strangely enough, the update does not have a semicolon after it. So depending on what it is, even if it's an increment or a decrement or an adjustment or the multiplication or division, whatever it is, there is no semicolon after it, which may seem strange because so many things, statements essentially that we've done, particularly inside of the body of a while loop, have had semicolons, but here we won't see that. And then of course, and again I'm going to put it on one line, we have the loop body and whatever it does. And what's nice about this is that in this body we are not required to write the update again. This update will happen at the end of every body no matter what code is inside of this, and that's convenient because we don't have to waste space in the body doing that. Another big difference, and so we should probably add a note to this, is that when it one of the big reasons that we might choose a for loop over a while loop, and this may seem silly because our examples have been very small, is that while loops require that our sentinels or counters are created before the loop begins, which means that they continue to exist in the scope after the loop ends. With the for loop, whatever variables you initialize or create, they do not exist after the loop is finished. And so this is a matter of security. If I have a variable that maybe contains a number that tells me how many times to repeat this loop, it may seem silly, but that number is a piece of information that someone either maliciously or unintentionally may use to mess up our program in some fashion. And so the shorter the scopes are for variables, the better off we are in general. It's a kind of a very simple kind of security principle. We say if it doesn't exist, they can't take advantage of it. And so we'll say if a variable is only used to move through a loop, then once the loop is over, if the variable disappears, that's a good thing. And so a for loop will do that for us. And so we don't have to worry about variables existing long term, as opposed to in a while loop, whatever scope the loop was in. So for example, in the main, then once we've created that variable num or n or whatever we called it, it will continue to exist and other portions of code may use it, and that could be a good thing, that could be a bad thing, and so we don't have to worry about that with the for loop. So let's go into our example, print the numbers from 1 to 10 inclusive. So print numbers 1 to 10 inclusive. So with the while loop, we did this before, and I'll go ahead and open up our program real quick just so we can see how we did that last time. And so here it was. Our sentinel was declared as num equal to 1. Our condition was while num was less than or equal to 10. Our work was printing. Our update was the increment, and we said we could do it all 3 different ways, but basically num plus plus go up by 1. And then we printed a message at the very end. And again, notice how we were able to print num after the loop because num existed before it. Therefore, it was accessible afterwards, which again, I just mentioned could be a potential problem. It allows us to reuse this without having to redeclare it, but if that's not something that's important, then maybe we shouldn't do it. So a for loop, let's go back to our for loop. So here we go. So the keyword for, and notice it does turn orange, and now the initialization. So in previous discussions, it was said that generally speaking, variable names should be expressive as to what they are. And so generally speaking, single letter variable names are a bad idea. Int x Unless x means something, so if we happen to be doing Cartesian coordinates, then maybe x and y have meaning. But if we just make a variable int x or int w, if it's not obvious to the user of the program or another programmer, then maybe that's not a good name. If the x was supposed to represent the number of students in a classroom, then maybe numstuds or numstudents would be a better variable choice. Now, with that said, for a for loop, this is one situation where kind of the tradition is to use single variable names, and it's not considered a bad practice. So for example, in algebra, typically when we begin with our variables in algebra, we use x, y, z. Those are the kind of starting variables, and then maybe eventually we might go to some other variable names. And so in our situation here for loops, the traditional variable name for the sentinel is I. And we start at I. If we have another loop, we might use j or k. So we do I, j, k, and go from there. L is typically avoided because L looks like a 1, so that could be confusing. And so depending on what we're doing, if we need lots of different loops, we may use variables. But one big advantage is that because the variables only exist in the scope of the for loop, we can use the same I again and again and again. And unless you're in a very specific scenario, you might not ever have to use another variable name, and that's very convenient and for a lot of situations. So let's declare the number, and this sentinel is just like with the while loop, going to be the number we print. So we'll say int I equal to 0. So that's our initialization. I exists for this loop and may be referred to inside the body as necessary. Our condition, what should be true for our loop to continue? The condition before was that num was less than or equal to 10. We can do the same thing. Oh, I made a mistake. Instead of being 0, there should be 1 because we're doing 1 to 10 inclusive. So there it is, I is equal to 1. Our condition was num was less than or equal to 10 or less than 11. So we'll say the same thing here for I less than or equal to 10. And you can see almost immediately the error, the red on this line is no longer an error, but we are missing our update. And so in our while loop, our update was num plus plus or num plus equals 1 or whatever we wanted to use. Here, the same thing occurs. The update is the third portion of our for header. And so in this case, we'll say I plus plus. And so here it is. And now the body, thankfully, is very simple. All we have to do is the work. The update is built into the header. So after the body, after line 23 to 25 run, then implicitly behind the scenes, this update will be run for us. So then I will become 2 and 3 and so on. And we don't have to do that work ourselves. And if we try to, we may accidentally make our loop go much faster than we expect because we might be doubling up how quickly we change I. So here I can just print out the sentinel value. So again, in the first situation, we had num, and we printed out num, and then we increased num. We printed out num, and then we increased num. The same thing's going to be here, but now it's just going to be the letter I. And that is the same. I could have called it num, but again, the tradition usually dictates that for loops use the variable I, j, and so on. And so there it is. Same functionality, prints the numbers 1 to 10. Let's go ahead and add that one extra line that we had said, which was finish, so we can see that it actually has finished. And here we go. Run file. Our program should build and compile, and there shouldn't be any errors, and there it is. There's the exact same result that we did if we ran the original while loop functionality. 1 to 10, and then finish. And of course, just like with the while loop, what makes this super flexible is I can change the condition or change the start. If I want the numbers 5 to 10 inclusive, then I change the I to 5, and it is initialized to 5. And now I'm only going to see 5 iterations. 5, 6, 7, 8, 9, 10. Or it's actually 10 iterations because it is inclusive of 10. So 5 is 1, 6 is 2, 7 is 3, 8 is 4, 9 is 5, and 10 is 6. That's 6 iterations or 6 loopings that occur. And so this is very convenient to control. And so I might say the number's 1 to 100. And that's as easy as adding an extra 0 and running it. And there it is. The loop occurs, and it is compacted. And then if to prove the concept that this variable only exists for the lifetime or scope of the for loop, let's try to do what we did in the while loop, which was to print num, or sentinel. Here we would try to print the I as our sentinel. So I would say system.out.println I, and we can see immediately there's an error, and it says, if we hover over our error, cannot find symbol variable I. It says, look, at this point on line 28, in this scope of main, which is dictated by these curly braces, there is no variable I. And that's a good thing for us in terms of security because I was only used for the loop, and now that the loop is over, I is gone. And so if I want to use I have to either declare it outside or create another loop or do something, but I does not exist after the loop is over, which is, again, generally speaking, a more positive statement than if it were not, or if it continued to exist. And that's something that we might try to avoid. So now we're going to go ahead and let's do another example, and we'll just try one quickly that goes backwards. And this is, again, the idea is the same concept. So let's print, and this is actually where a for loop I think kind of shines, is since we're basically, if we know how many times we want to loop, then a for loop tends to be easier to write than a while loop. I mean, they're basically the same, but in my opinion, they're a little bit less tedious to write. So I want to print numbers 100 to 1, 100 to 1, inclusive, except if the number is a multiple of 21, print the word, I don't know, cheese. Right? So we'll see the numbers from 1 to 100 going down, but if we see a number that's a multiple of 21, we'll instead print the word cheese instead of the number. So at 21, we won't see 21, we'll see 22, cheese, 20. And it's for every multiple of 2 underneath it. So let's go ahead and try doing that. Again, the same concept will apply. We'll use our for keyword. Our initialization, where does our loop begin? What does our CentOF value start at? If we're going from 100 to 1, then we can say that our int I is equal to 100. We begin with 100. Our condition should be true to continue working. Well, as long as I is a number that's greater than or equal to 1, then I want to try to print it out. So at 7, it should print. At 35, it should print. At 42, we would print the word cheese. And at the number 1, we would also print. So while I is... So again, you might say in your head as a while, you'll say, if it's true that I is greater than or equal to 1, which is inclusive, then we would continue working. And then here our update is not an increment, but a decrement, because we start at a big number like 100, and we wish to go down, then we're going to subtract 1 at a time, or subtract 5 at a time, or subtract 21 at a time is a potential solution. But the idea is that I'm going to go one by one just in case, and then we'll ask maybe a question in our body. So we'll say I minus minus. And I'm allowed to do this. If you really want to do it, you can do I minus equal 1. That's acceptable. Or if you want to be very expressive, I guess you could also say I equals I minus 1. None of those are a problem. Notice how there is no semicolon, though I mentioned that before. But again, this is where kind of these increment and decrement operators kind of shine and appear a lot, especially in AP exam code and other people's code, because it's so easy to write go down by 1 or go up by 1 as a plus, plus, or minus, minus. And so here we are, we're going down. If I were to print out the numbers just right away, then it would just print the number. But we have to ask a question. Is it a multiple of 21? And if so, print the word cheese. Otherwise, just print the number. So let's ask that question. If. Again, the sentinel in this case also happens to be the data that we're trying to work with. So I can use I as my value to be considering. In this case, we would say if I is evenly divisible by 21, which means it's a multiple of 21, then we would print out the word cheese, right? Oops, let me get rid of that. And then otherwise, for every other number, we would do print out that number. So we print out I. And so again, the idea is these are mutually exclusive things. Either you're a multiple of 21 or not, so an if-else is a very convenient structure to make happen. I'm going to make sure that I comment this line out so it doesn't cause a problem. And let's put a note at the end of it saying, I does not exist outside of the for loop. Right? So that's important to note. And so let's try this out and see what happens. I'm going to run it. And there we are. And let's go up from the 100. Notice it is backwards, which is convenient. So there it is. 100, 99, 98, and so on. 86. Right? 4 times 21. I'm sorry, not 86, 84. 4 times 21 is 84, and therefore we see the word cheese. And then 3 times 21 is 63, and there it is. And then 2 times 21 is 42, and there it is. And then 1 times 21 is there. And then 0 theoretically could be it, but we're not printing 0. We're only inclusive up to 1, so it stops. If you were to be asked how many iterations occurred, what would our answer be? We started at 100, we went to 1, and we're inclusive of 1. So from 100 to 1, if we did from 0 to 99, that would be 100. So from 1 to 100 would also be 100. So this is convenient. And again, it isn't basically inclusive of the 1 and of the 100, so that is 100 iterations that occur. Could we have done it shorter? Absolutely. We maybe could have started at 84 and then just subtracted 21 each time. So that would have only iterated 3 times because it would have been by multiples of 21. But if we want to print every number, then we can't really use that shortcut, and therefore we have to loop through every single number. So this is convenient. So now let's just go and try something more interesting, and we did last time as well, manipulations with strings. And so I'll also point out for loops also tend to be very effective when dealing with strings, usually because when we work with the string, we want to look at every character or look at every other character. We have a set distance or number of iterations to occur. If there are 20 characters in a string, you're probably going to loop 20 times if you want to see all of them. If you have if you have a string with 10 characters and you only look at the even positions, then that's 5. Again, a for loop is useful and easy to write typically if you know the number of iterations roughly that you want to do. Because the sentinel will be set up, the update will occur, and our condition is the same as if we had a while loop. So why don't we attempt to move through a string and print it out backwards? So if you give me the word hello, you end up with O-L-L-E-H. If you give me the word Bob, you end up with B-O-B or Bob again, right? So the idea is that whatever string you give it, we can reverse it. And then of course an empty string reversed would also be an empty string. So let's make something that does that. So we'll make a string to test with. We'll say string text, and we'll start it off with that word hello. And if that works, then we can probably test it on different scenarios. So here, a for loop I think shines. What is the starting point? If we're manipulating a string, what are we doing? We're looking at each individual character, and hopefully we remember, if we want to look at each character, we're going to look at the index of each character and retrieve the value at that index. So at position 0, what is the index, and so on. But in this case, we want to go backwards, so we have to start at the last index. And if we have a string and has a length n, what is the last safe index that we can use? And that would be n minus 1. So if there are 6 characters, the last safe index is 5. If there are 20 characters, the last safe index to use is 19. So we can generalize, and now instead of setting n, we can say if there are length characters, right? Because length is a property of strings, a method that we can call to get that number, then length minus 1 would be the last safe index. So let's go ahead and set up our for loop. Our initialization, again, we're going to use I. That's kind of the tradition. You don't have to, but it's not terrible practice to stick with that. And then we're going to initialize not to 0, which again is the first index of strings, but since we're going backwards, this would be useful to start at the end. And I said that the last safe index is the length of that string minus 1. So we're going to say text dot length minus 1. That's our initialization. Our condition should be what should be true for us to continue. If the index is anywhere from the length minus 1 up to and including 0, because the first one would be 0, then we should continue the work. Whatever that is, in this case, putting the characters together backwards. So let's go ahead and say while our I is greater than or equal to 0, because we include 0 because it is a valid index in a string. If we said greater than 0, then we're basically ignoring the first character, which can happen, but that's a typical kind of flaw in when we make our loops, is kind of stopping early. The two most common errors are stopping early or stopping late and causing a crash. Stopping early does not cause an exception, but you'll maybe miss data. Stopping late will usually cause either a string index out of bounds exception or a couple other errors that may occur. So we have to be very careful with that. But in this case, we're inclusive of 0. And again, if we're starting at a big number, length minus 1, and we're going down, we're probably going to decrement. And since we're looking at each character, we're going to say I minus minus. It's a good choice to go down by 1 each time. So now I, in this case, does not refer to a number that we're printing. It refers to an index. Right? It's all about context. The context of this loop is that I could be used as the index as well as the sentinel, because it's saying, well, as long as the index we're looking at is a good index, safe within the range, then we can use it to our advantage to look into a string. So now there's one thing that we're missing. We're not going to manipulate text. We can't really edit text because strings cannot be changed. Every method that we've seen, substring, two uppercase, two lowercase, they return new strings. So why don't we build from nothing the string that we want? So if text is what we want, then let's maybe make a string that's called reverse, and we'll start it off empty, and we'll kind of slowly attach from the emptiness the characters that we see backwards, and the result will be a backwards string. So if we have our variable reverse, then we can say, why don't we retrieve, and we'll call it next char, and the name is not important. You don't have to even put it in a variable, but I'm going to just to be expressive. The next character is which one that we're looking at. It's at index I, but how do we retrieve a single string of a one character from the substring method? We'll say text.substring, and I believe we did this last time, but essentially, if I have position I, if I'm doing substring from, let's say, 3 to 4, that would be index 3 up to 4, not including 4, so I would just get what's at index 3. So if I want to get one character at I, then I'm going to go from I to I plus 1, because it would go from I to I plus 1, not including I plus 1, and therefore we would get the string or the character at index I, which is just one character, which is what we want. So we have the next character, and now let's attach it to our reverse. And I'm going to use plus equals, and I'm just going to point out, if we go backwards in a string and we attach each character to the end of reverse, then we get a reverse character. If I happen to attach it to the front, then I'm going to get the same string. So imagine if I look at the O and I add it to the front of the empty string. Okay, it's an O. And I look at the L and I attach it to the front. I'm going to end up with LO. And then I see another L, and if I attach it to the front, I'll get LLO. So I'm going to end up with hello on accident. So it's important that we're saying, and this is why it's maybe not obvious because we're using plus equals, so it's just assumed that we're concatenating to the end of reverse, but that could be potentially not what we're aiming for. So if I did something like this, reverse plus next char, this is what we're actually doing, which is okay, but if I somehow flip these, then we would get the same string back and not the reverse. So let's just be clear that it is attaching the next character to the end of the string. Plus equals attaches it to the end, so does this operation. At the end of our loop, I doesn't exist anymore, but reverse does because it was created outside of it, and it should have all the characters in reverse order. So let's print out our things. We'll say original, and we'll say, we're going to attach it to whatever text was, and then we'll print out our reversed one. And let's see what reverse looks like. So here we go. I'm going to run it. Original is hello. There's our new one. Looks like it's good. Let's test it on. So typically we can test on for strings. It's useful to test on 3 categories. Strings of size 0, empty strings, because those are usually special cases, and certain substrings we might mess with those things or may be ineffective at a size 0. Though I think in this case it'll work out for us. But that's something we can consider. Size 1, because sometimes strings of size 1 are unique instances, and we have to handle those in a different fashion. And then strings of any arbitrary size. We've already seen arbitrary size, character size 5. Let's do empty string. The reverse of an empty string should be an empty string, so we should see 2 blank lines. And no crash. Oh, I'm sorry. I changed it. Let's do this one to empty string. So here we go. So let's try it now. There it is. Empty string reversed is an empty string. Looks good. A single character reversed should be a single character. And there it is. And now if we do AB, that's 2 characters, or any size larger, we should get the reverse, which is in this case BA. And if I put ABC, then we should get CBA, and then so on. So we've covered all 3 kind of big scenarios. And in fact, what this proves to us is that this loop is flexible enough to handle all kinds of strings, right? But again, it's because the question we're solving, reverse the string, is an easy one to solve, and it doesn't have any special cases, right? The reversal of an empty string is essentially the same work as the reversal of any size string. So I'm going to stop the video here, and we'll continue in another video with some other examples. We've essentially established a for loop. There's not much else to it. It's just a matter of comfort with the different scenarios. In this case, we've used numbers only, but there are many different ways of using for loops to take advantage of things. We'll maybe see for loops when it comes to user input, or while loops with user input, right? That's a different scenario where loops become convenient. And now instead of assuming some set number of inputs, we might be able to take advantage of any number of inputs, an unlimited amount, or until a user types something that we expect them to stop. So I'll see you in the next video.